next topic which I will discuss is anesthesia machine. Now, anesthesia machine. It's a very small topic, but very important. Why important? Because you just have to know a fact. If you know the fact, and all the questions of machine would be solved. You don't need to have a lot of clinical acumen or clinical sense to solve questions for machine, etc. Fact and answer is right? We just have to know a few facts in machine which can be asked in exam, which is being asked in exam, right? Now, who was the first person to design machine? The credit goes to Dr. Edmund Boyle. So first machine was designed by Dr. Edmund Boyle, right? First machine was designed by Dr. Edmund Boyle, right? It was called Boyle's machine. It was called Boyle's machine. Got it? So Dr. Edmund Boyle designed the first machine called Boyle's machine. Got it? Okay. But today we don't work on Dr. Boyle's machine. We work on a very sophisticated version of Dr. Boyle's machine. We work on anesthesia workstation. So modern machine is called modern machine is anesthesia workstation, right? It has a lot of safety features. It has a lot of new things added to it. It has ventilator incorporated in it. It has monitors incorporated in it. It's a very sophisticated version with a lot of safety features. But the basic design of Dr. Boyle's machine and modern anesthesia workstation is still the same. So let us discuss a basic design of anesthesia machine, right? And then I will tell you the most important addition done in modern anesthesia workstation. Got it? So let us discuss a basic design of anesthesia machine. See this box. Okay? And imagine this box as your machine, right? Try to see the back of machine. What is attached to the back of machine? Cylinders are attached. Side walls or the roof, what is attached? Pipeline is attached. And the front of machine, what you see when you see it. What you see when you see it, right? This is the front of machine. Now see on the screen, this back of machine, what is attached? Gas cylinder. For example, this is oxygen cylinder. This is nitrous oxide cylinder. This is air cylinder. If oxygen cylinder is fully filled, okay? If oxygen cylinder is fully filled, what is the pressure? 2000 pound square inch. The pressure is 2000 pound square inch. Right, everyone? Now this 2000 pound square inch is the unit of pressure which is used in terms with machine, the cylinder and machine, etc. So oxygen cylinder has a pressure 2000 pound square inch. Your and my lung can tolerate a maximum of 10 to 12 pound square inch pressure. So when oxygen is taken from cylinder into the machine, it is taken at a very high pressure. And then it is passed through the machine. And ultimately we receive at a very low pressure which our lung can tolerate. In machine, there are a number of pressure reducing valve which reduces the pressure of the oxygen flowing oxygen. So from this part of the machine, where they receive gas from cylinder at a very high pressure, has a very high pressure, and that part of the machine is called high pressure system. So first part of machine which I will discuss with you, high pressure system. Okay? So we will discuss the first part of the machine, high pressure system. Okay? So this is the first part of the machine which I will discuss. In this I will discuss the part of machine on which cylinder is mounted, and I will discuss with you gas cylinder also here itself. Okay? Right? So I will discuss it in high pressure system. Then see the roof of machine or sidewall. What is attached? Pipeline. This pipeline supply comes under the second part of the machine. We call it intermediate pressure system. Right? We call it intermediate pressure system. The second part of the machine, intermediate pressure system. So this is the second part of the machine, intermediate pressure system. Okay? And see the front of machine. what is attached, whatever you see in the front of machine, they come under the third part of the machine, that's low pressure system. Low pressure system. This three-part division of the machine, high pressure system, intermediate pressure system, low pressure system, has been done on the basis of pressure in the machine, difference in the pressure in the machine, right everyone? So we have three parts of the machine, high pressure, intermediate pressure and low pressure. Okay, so let us start our discussion with the first part, that's high pressure system. High pressure system. What I will discuss in this? I will discuss first here gas cylinders, right? Gas cylinders. Well, I showed you the picture of gas cylinders, right? Isn't it? We discussed the picture of gas cylinders. I showed you nitrous oxide cylinder. I showed you oxygen cylinder. So we have color coding for the cylinders. We have to know different gas cylinders, color coding. We have to know different gas cylinders, pin indexes. These are the simple questions asked. First of all, what is the gas cylinder made up of? It is made up of steel and molybdenum. Steel and molybdenum. Okay. Now what are the sizes? I showed you few sizes. The sizes vary from A to HH. A, B, C, D, E, F, G, H, HH in increasing order. Right? A to HH in increasing order. Now there is one question asked in exam that a patient requires MRI and is to be shifted to MRI room. What is MRI compatible oxygen cylinder made up of? For MRI room, we have a whole set of things made up of MRI compatible materials like machine, cylinders, everything made up, laryngoscope made up of MRI compatible materials, right? And the cylinder which is MRI compatible was initially made up of aluminium, right? But later on, since aluminium does not have a very high tensile strength, later on, what was done? Nowadays it is made up of titanium. Titanium, the cost increased, but definitely the longevity of the machine is better. So both can be the answer, aluminium or titanium. So just write it. MRI compatible cylinders. MRI compatible cylinders made up of aluminium or titanium. Okay, aluminium or titanium. Got it? Okay. Now size A to HH is the size varying. Only one question is asked. What size is attached to the machine? Type E is attached to the machine. Type E is attached to the anesthesia machine, right? So type E cylinder only has the pin index system incorporated in them to attach it to the anesthesia machine. Got it? Now let us discuss few gas cylinders, their color coding, their pin indexes, and some clinical questions asked on them. Okay, so let us start with oxygen. Oxygen. Well, oxygen cylinder, you all know, has black body, white shoulder. Black body, white shoulder. Black body, white shoulder, right? And it has a pin index of 2 and 5, right? And the pressure of oxygen cylinder when it is fully filled, it is 2000 psi. This is the pressure. Okay, this is the color coding, and this is pin index. Okay, guys, whenever I enter OT and I have to work on this machine, I have to use this machine to give general anesthesia. Every day when we enter OT, first thing which we do, check the machine. And in machine check, one of the first thing which we check is pressure of oxygen cylinder. Well, if you see this machine, back of the machine cylinders are attached. We have a key which will open the cylinder. I open it. These are pressure gauge indicators, pressure indicators of different cylinders. I open the oxygen cylinder and see the pressure in the front of machine, right? If the pressure of oxygen cylinder is, let's say, less than 1000 psi, if the pressure is less than 1000 psi, right? I never start a case. That means cylinder is less than half filled. I never start a case. It is mandatory to change the cylinder and then start a case. We never can start a case when the cylinder has a pressure of less than 1000 psi. Got my point, everyone? Okay. So they asked this question in All India Entrance Exam. What is the minimum mandatory pressure of oxygen cylinder to start a case under general anesthesia? What is the minimum mandatory pressure of oxygen cylinder to start the case under general anesthesia? Got it, everyone? Minimum mandatory pressure of oxygen cylinder to start a case under general anesthesia is 1000 psi. Right? It is 1000 psi. Right, everyone? Okay. Very important. This was asked in All India Entrance Exam, and the next year they asked. Type E oxygen cylinder was showing pressure 1000 pounds scavenge. At a normal flow rate of oxygen 2 to 3 liters per minute, how long the cylinder would last? Guys, type E cylinder of oxygen at 1000 psi, giving oxygen at a flow rate 2 to 3 liters per minute, right? 2 to 3 liters per minute would last for 2 to 3 hours. It would last for 2 to 3 hours. Got it? So type E oxygen cylinder at 1000 psi pressure, giving oxygen at a flow rate of 2 to 3 liters per minute, would last for 2 to 3 hours. Just we have to remember this, right? Because this is a fact which was asked in exam and you have to memorize it. Minimum mandatory pressure 1000 psi, and if flow rate at 2 to 3 liters showing 1000 psi, it will last only for 2 to 3 hours. It will get empty in 2 to 3 hours, right? So this is all about oxygen cylinder. Next is nitrous oxide cylinder. Nitrous oxide cylinder has color coding blue, pin index 35 and pressure 760 pounds square inch. Okay. Air, grey body, black and white shoulder, 1.5, right? Right. Then carbon dioxide, grey, and 2 pin index 1626. Pressure you have to remember only of oxygen and nitrous oxide, not of other gases, not asked in exam. Only try to memorize the things which are asked in exam, right? So 1626. If carbon dioxide present in the cylinder is more than 7%, it is 16. Less than 7%, it is 26. Got it? More than 7%, 16. Less than 7%, 26. Okay. Then guys, cyclopropane. What is the cyclopropane? Well, it has historical importance. It is a potent inhalational anesthetic agent. But we all have studied potent inhalational anesthetic agents are stored in vaporizer. But this gas could not be liquefied. So it was stored in cylinder. And the cylinder was of orange color with a pin index of 36. Got it? So this has just historical importance, right? So this is all about the color coding and the pin indexes of the cylinder. There is one more cylinder asked in exam, not given in most of the books, but keep it in mind, that is helium cylinder. Helium cylinder. What is this helium cylinder? Actually, it is not helium. It is not helium. It is heliox. Helium plus oxygen. Right, it is heliox. Helium plus oxygen. Right? Guys, why do we mix helium to oxygen? See, oxygen in pure form, 100% oxygen, has very high viscosity. So when you breathe 100% oxygen, the work of breathing increases immensely. If I want to give my patient oxygen, right? But I don't want work of breathing of the patient to increase because already the work of breathing is more, airway pressure is high. Let's put up a clinical scenario. This is your glottic opening, this is your trachea and right and left bronchus. Got it? Let's say patient has COPD and the constriction of the bronchus has happened, respiratory tract has happened. So the diameter is decreased, already airway pressure has increased. Patient is becoming hypoxic because work of breathing has increased. Just to help our patient, to increase the PaO2 of the patient, I am giving 100% oxygen. This 100% oxygen is very viscous, as I told you. Work of breathing further increases and patient is unable to take that 100% oxygen. So what do? We give heliox. What is the benefit of giving helium plus oxygen? Guys, this helium added to oxygen has very important three roles. Number one, it decreases the viscosity of oxygen. Viscosity. Second, it decreases turbulence of the oxygen. And third, it decreases work of breathing. It decreases work of breathing, right? Guys, so that's why heliox is just oxygen delivering devices. Now helium plus oxygen. Okay. The amount of helium added is to oxygen out of two composition. 70% helium, 30% oxygen. And 60% helium and 40% oxygen. Okay. We have two kind of heliox. Both 70-30, 60-40. Right? Both 70-30, 60-40 of heliox. Both are stored in a brown color cylinder. Brown color cylinder. Right? Both are stored in a brown color cylinder. And they have pin indexes. Pin index 2, 4, 4, 6. 2, 4 and 4, 6. Got it? So this is what is heliox. Sometimes asked in exam. So keep it in mind. Okay? Okay. This is all about cylinders. Now coming on the part of machine where cylinder is mounted. Let us say this is the back of machine. This is the back of machine on which cylinder is mounted. Okay? This is the back of machine. Okay? Now let's say here we have something called pin index. Right? This is oxygen attachment site. So second and fifth pin is active. We attach oxygen. Nitrous oxide, third and fifth pin is active. We attach nitrous oxide. Air, first and fifth pin is active. We attach air cylinder. So cylinder is attached. Now this part where the pins are located for the attachment of cylinder, that's called yoke assembly system. Yoke assembly system. So they ask, where is the pins of pin index system located? These are pins present on yoke assembly system. So it's present on yoke assembly system. We have to keep it in mind. Okay? The cylinder is mounted on the pins and a nipple is present at the junction of cylinder and the pin to give a very good seal for the passage of gas. This nipple provides a seal which prevents leakage of any gas while going from cylinder into the machine. Right? So this nipple needs to be intact to prevent leakage of gas from the cylinder. Right? This is about high pressure system. Now coming on intermediate pressure system. Intermediate pressure system. Right? Intermediate pressure system. What comes under this intermediate pressure system? The first thing which we have to remember is pipeline supply. Pipeline supply. Okay. Pipeline supply comes under intermediate pressure system. Okay. Now guys, you may have seen, gases supplied through machine can be supplied from two sources, pipeline and the cylinder. Pipeline, the central gas plant where gases of medical uses are being prepared, oxygen, nitrous oxide, air, and through pipeline it is supplied to the hospital complexes or to the, let's say, oxygen operation theater, etc. Now this pipeline is the main source of gas from machine, because it's a continuous source of gas, right? Cylinders are our backup if anything happens to pipeline, because it is a distant source. We open the cylinder and get the case done. But pipeline is the main source, right? Remember. So pipeline supply comes under intermediate pressure system. And if you may have noticed color coding for the pipelines, you may have noticed white color pipeline, blue color pipeline, right? And black color pipeline, and let's say yellow color. White color is for oxygen, blue for nitrous oxide, and black for air. Got it? White oxygen, blue nitrous oxide, black air. Okay? All these three pipelines, right, are supplying the gases at 55 to 60 psi pressure. This is the pressure of intermediate pressure system, 55 to 60 psi pressure. This is the pressure of intermediate pressure system. Okay. Yellow is the vacuum pipeline, central vacuum pipeline. Okay? Okay. Now guys, what is pin index system? We have already discussed. It is a system which prevents incorrect attachment of cylinder to machine. Similar problem can also happen with pipeline if I attach incorrect pipeline at the wrong site. In order to prevent that mishap, another safety system has been added to the machine, that's called DIS, diameter index safety system. So third is DIS. What is this DIS? Diameter index safety system. Diameter index safety system. What is this? This is a safety system of pipeline supply which prevent attachment of wrong pipeline to the cylinder, to the machine. Every gas pipeline's terminal diameter had been made unique for that particular gas, so that interchanging of the pipeline does not happen when we attach it to the machine. So what is this DIS? It is a safety system. Safety system which prevent incorrect attachment of pipeline to anesthesia machine. Got it? Incorrect attachment of pipeline to anesthesia machine. Got it? So this is our DIS, a safety system which prevents incorrect attachment of pipeline to anesthesia machine. Got it, everyone? Okay. So this is our DIS, a very important point, guys. This question has been repeatedly asked, that what is DIS? Is it a safety system which prevent incorrect attachment of pipeline to the anesthesia machine? Got it? Okay. Now there is one more part of intermediate pressure system, something called emergency oxygen flush. This emergency oxygen flush is located in low pressure system, but it is a part of intermediate pressure system, right? Well, if you have seen the machine, just see this machine, just let's say beside the common gas outlet, there is a black button surrounded by a white halo, right? This is the black button surrounded by a white halo. This is called emergency oxygen flush, right? What is the use of this? This is a machine. Okay. This is the oxygen and nitrous oxide flow control valve, which are the parts of low pressure system. How do I give my patient the oxygen from machine? I turn on the oxygen flow control valve, and from common gas outlet. This is common gas outlet, from where whatever gas you start in machine will come out. From common gas outlet, maximum oxygen which can I give by this way is 15 liters at 10 to 12 psi. 15 liters at 10 to 12 psi, right? Now my patient is in bronchospasm, or my patient is in laryngospasm, and I have to give more oxygen. How do I give it? Now there is a black button I talked about surrounded by white halo. I press it. When I press it, per press releases from this common gas outlet 35 liters of oxygen at 55 to 60 psi. This pressure is part of intermediate pressure system, but this is located in low pressure system, right? It has pressure of intermediate pressure system, this emergency oxygen flush. This is called emergency oxygen flush. Got it? This is called emergency oxygen flush. Okay. What are the question asks? What is the pressure of emergency oxygen flush? It's intermediate pressure system pressure, 55 to 60 psi. How many liters of oxygen come out per press of emergency oxygen flush? Minimum 35 liters, guys. Some machine has capacity to give more oxygen, but minimum should be 35 liters. Got it? Which every machine has to fulfill. There are a lot of companies which manufactures machine. Every company has to follow some norms, and this is the norm that minimum flow should be 35 liters. Got it? So this is emergency oxygen flush, and these are the parts of intermediate pressure system. Now comes the third part, low pressure system. Low pressure system. Okay? See this. Whatever you are seeing in the front of machine, most of the things come under low pressure system, right? See, these are oxygen nitrous oxide flow control valve. Well, front of machine has this oxygen, nitrous oxide, air flow control valve. This whole system of showing the flow of these gases from machine, this is called flow meter. This is called flow meter. The individual indicators of flow, nitrous oxide indicator, air indicator, it's a conical indicator which rotates on its axis. This is called rotameter. Rotameter. And this tube which tells us about the flow, this is called Thorpe's tube. Thorpe's tube. So we'll write it, right? Just understand. Then this vaporizer, this also comes under low pressure system, right? This common gas outlet, this also comes under low pressure system, right? And a very important thing which comes under low pressure system, hypoxia guard. Okay, so let us first write parts of low pressure system. Okay, first part, oxygen and nitrous oxide flow control valve. Then vaporizer. Then common gas outlet. And then your hypoxia guard. Hypoxia guard. So let us first talk about this oxygen and nitrous oxide flow control valve which I was showing on the machine. Oxygen and nitrous oxide flow control valve. This whole system of these flow, this is called flow meter. This is oxygen flow control valve, this is nitrous oxide flow control valve, and this is air flow control valve. Okay? Individual indicators, it's called rotameter. Guys, I have turned on the oxygen flow control valve and 3 liters of oxygen I have started. The lower end of the rotameter is on 2.2 liters or 2.5 liters and the upper end is on 3 liters. So what is the flow? It's 3 liters. So upper end of rotameter indicates true flow. Upper end of the rotameter indicates true flow. Got it? This tube which we were talking about, this is not a tube with uniform geometry. Since wide range of flow has to be shown, so lower part of the tube is cylindrical and upper is conical. This special tube was made by Thorpe's and on his name it's called Thorpe's tube. Thorpe's tube. So this tube is called Thorpe's tube. Got it? This is all about oxygen and nitrous oxide flow control valve. So this is called Thorpe's tube. This is flow, whole system is flow meter and individual one is called rotameter. The individual indicators is rotameter. It rotates on its axis. Now vaporizer, I don't have to study anything with you. We just have to know about color coding, which we have already discussed in inhalational anesthetic agent. We discussed halothane as a red color vaporizer, isopurple, sevoflurane yellow and desflurane blue. Common gas outlet. This is the machine and this is the common gas outlet. Common gas outlet of machine. What is attached to the common gas outlet? Circuit. Right? Between common gas outlet and circuit, we have oxygen analyzer attached. Right? This is the exit point of the machine. Okay? Then comes very important part of machine, hypoxia guard. Hypoxia guard. Guys, whenever we give any gas to the patient, inspiratory gas from machine, it should have a minimum mandatory oxygen present in it. Well, by mistake, if I forget to open the oxygen, I can give a hypoxic mixture. Mishaps can happen. In order to avoid any such mishap, there was a hypoxia guard incorporated in machine. That is, machine, some safety features were added which prevented us from giving a hypoxic mixture to the patient, hypoxic inspiratory mixture to the patient. 3 important changes was done in modern. This hypoxia guard was not present in Boyle's machine. This was only present in modern anesthesia workstation. 3 important changes was done. First, guys, when I go to the OT, and the first thing which I do, I check the machine. How do I check it? I open the master switch of the machine. Okay? I have to open the master switch. Without it, the machine would not start. As I open the master switch, machine itself starts a minimum mandatory oxygen flow. I haven't started oxygen. Machine has started oxygen. So there is a basal oxygen flow of machine which starts with master switch, not with the oxygen flow control valve. So that much oxygen you cannot deny to any patient, right? So first hypoxia guard, basal oxygen flow of anesthesia machine. Anesthesia machine. Right? The second is second hypoxia guard. Now this is the flow meter. Okay. It has 2 flow control valve. Right. Rather 3, 1 for air also. Guys, any time during anesthesia, do you want to give 100% nitrous oxide? Never. We want to give 100% oxygen, but never nitrous oxide. If I turn on the oxygen flow control valve alone, I will give only oxygen. But if I turn on the nitrous oxide flow control valve alone, if 3 liter of nitrous oxide starts, 1.5 liter of oxygen itself will start. If 4 liter of nitrous oxide starts, 2 liter of oxygen itself will start. Nitrous oxide never opens alone. It opens in a fixed proportion with oxygen, right? So even if I just turn on the nitrous oxide flow control valve, by mistake, a minimum oxygen will also go to the patient. So nitrous oxide opens in fixed proportion with oxygen, right? So nitrous oxide opens in a fixed proportion with oxygen. And the third hypoxia guard is oxygen analyzer attached to the machine. Oxygen analyzer. Final gas which I am giving to my patient. This is machine's outlet. Here what is attached? Circuit. Between them is oxygen analyzer. The final gas which I am giving to my patient, this is analyzed for its oxygen concentration. If it is below mandatory, there are alarms in the machine. We have oxygen alarms in the machine. Oxygen alarms. So it will start ringing. Okay? So whatever we do, we can't give a hypoxic mixture to the patient. We can't give the hypoxic mixture to the patient. Got it? These are our hypoxia guard, which prevent us giving hypoxic mixture, inspiratory mixture to the patient. Okay? This is all about our low pressure system and all about machine. Before finishing up this topic, the last point which I want to tell you, the question is asked in AIMS on machine that flow of oxygen in modern anesthesia machine is upstream, downstream, any stream, what? Remember, flow of oxygen in modern anesthesia machine is always downstream. That is downstream, upstream, these are direction of flow. If the direction of flow is from cylinder towards common gas outlet, it's called downstream. From common gas outlet towards cylinder, it's called upstream. So remember, the flow is always downstream. So write the last point. Flow of oxygen in modern anesthesia workstation is downstream. Got it? So this is minimum we have to know in anesthesia machine. Very simple, straightforward topic. You just have to know few facts and other questions are done. Okay? So this is what we have to know in machine. Thank you.